All right. Good afternoon. Hopefully we are actually live in some places. I have utterly failed to figure out Restream still. So hopefully no one is stuck watching the wrong stream. There is unfortunately a wrong stream on YouTube, I think, that we're not streaming on, but it says it's Deep Dive, but then there's a separate one that we are streaming on. If anyone here is watching on YouTube, please leave me a note in one of the chats letting me know that you can see and hear me so that I know that YouTube is actually working. And while we're doing that, I'm going to try to fix the chat because this chat will be for the wrong stream, I assume. What's this? That's very strange that that's still there. I can see you. Thank you, Vince over on YouTube. I appreciate it. In here. Nice. Okay, so the chat. That's weird that it still shows the old YouTube chat after I closed. Just gonna. There we go. I'm watching on YouTube as well. Thanks, Joseph. I appreciate it. Okay. Let me do one thing, which is let's try to drop the link for the correct stream in the incorrect one's chat so that if anyone happens to be over there, I do not need to hear myself. Let's turn that down. If anyone is on the wrong one, hopefully hopefully they'll see this and move over. And I'll try to figure out how to delete the wrong one at some point as well, but I'm not going to do it right now because with my luck, I will mess it up and delete the wrong one. Okay, put that in the chat. Close this. All right, welcome. Thanks again to the folks in the YouTube chat. I do appreciate you dropping the notes in there so that I know that we're actually good. Let me shuffle around a few windows here, and then we will get the show on the road. 1 second. Let's see. I need to do one thing. Let me do this. And we're back. There we go. What's up, Yano? Nice to see you this evening, my friend. Coffee cheers. Mine's a little full. So I'll be careful drinking that for the next couple of sips. Yes, let me put this here. Hi from Washington. What's up? WA9 Oni? WA9 Oni? Nice to see you this evening, my friend. Thanks for tuning in. Yes, so welcome. First of all, thanks to everyone who is watching. This is the Deep Dive, which is a weekly live stream program. If you are new and you don't know, haven't caught it before, my name is Tim. I go by Foamy Guy on GitHub and Discord. I am filling in on this stream for Scott, who does typically stream at this time each week during the Deep Dives when he's around. Scott's the one who started this. He is out this week, and I am here filling in. If you are new and you haven't caught it before, Deep Dive, typically what this is about is just working in the guts, so to speak, of CircuitPython. Scott is the lead developer, so he is typically working very low level inside the CircuitPython core. I usually do work a bit of a higher level, although last week we were inside the core, so we were digging around in there a bit as well. This week we'll be at the Python layer, but we are playing with some cutting edge stuff, so this stream is still kind of a deep dive into some brand new functionality within CircuitPython. And to cap it off, if you are brand new and you happen to not know about anything that I just said and you don't know what CircuitPython is, you can learn more at the main website for the project, which is right here, circuitpython.org. This is basically a version of Python that runs on tiny computers called microcontrollers. And if you choose to use CircuitPython with it, the way that it typically works, you plug it into your computer with a USB cable. It shows up like a thumb drive, and then you can edit some Python code on that thumb drive. And then when you save it, the tiny computer that's actually on these little devices will execute that Python code for you, and then your code can interface with whatever other peripherals you hook up to the microcontroller. So lots of these little microcontroller devices are general purpose. They have loads of these pins along the outside edges, which you can connect whatever you want to. But others are more purpose-built. If we search up something like the PyPortal, it's kind of a little tablet form factor. It's got a touch screen. It does not have loads and loads of I/O pins. There are a couple there that you can still hook a few things up to, but nothing quite like the Pico here, where it's just rows and rows of pins. You can hook up loads of different things to this. So some are purpose-built, some are general purpose, but the 585 of them on this page all share one trait, which is that they can run CircuitPython. Who's working on the Python language itself? Thanks for explaining. Yes, the CircuitPython language, to be clear. So we are working on the Python that runs inside of these microcontrollers. And then, not to muddy the waters too much further, if you are new, but there is also MicroPython, which CircuitPython is a fork of that. So that's a bit of a different flavor of Python. It still runs on microcontrollers. CircuitPython is a fork of that that adds the USB storage and a bunch of driver layer stuff. All right. So jumping in today, I have the OBS set up here to capture the output from the Fruit Jam. Let me jump over to the camera as well, and I'll show you. So I owe a hug report. Speaking of Scott, let me also say, actually, before I forget, as always, thanks to Adafruit. Adafruit is the company that makes not only CircuitPython possible, but this stream and all of the stuff that Scott and I work on. Adafruit pays the folks who work on CircuitPython, and that's really cool of them. CircuitPython itself is an open source project. Anyone's allowed to use it. You're allowed to port your own microcontroller to it. You don't have to pay a fee or anything like that. Anyone's allowed to do that. Anyone's allowed to use it in your own projects. You can use it for commercial projects, personal projects, whatever you want. All of that is super duper cool, and the way that that is possible is Adafruit paying the team of folks, including myself and Scott, who work on CircuitPython. So huge thanks, as always, to them. And if you want to help support the team that work on CircuitPython and the project itself, one of the easiest ways to do it is just purchase hardware from them at their website at adafruit.com. You can get not only the microcontrollers themselves, you can get all sorts of little doodads to hook up to your microcontrollers to play with. Nearly 600 boards, yeah. We are getting pretty close. We are getting pretty close up on 600, aren't we? Okay, and then I did want to say, speaking of Scott, I owe a hug report to Scott this week. Scott tested out this EVGA XR1 Lite, which is an HDMI capture card that happens to be on sale, which is pretty cool. And it works great with the HSTX output. So either output from a Metro RP2350 or output from a Fruit Jam. I happen to have the Fruit Jam upside down because that's the way that my HDMI cable wants to sit right now. But basically I have, DVI with an HDMI cable, right? It comes out through here. It goes into the XR1 on this far end. You can't really see it, but it's over there. It goes in. It comes out on this side as HDMI, which I can then plug into this monitor. So I can see this screen with the same stuff that is also being captured with OBS. This one right here is a USB. That goes back into the computer. And then OBS is able to see this input as a camera, basically. So this is really cool that we can capture it directly from the card, and we get nice crisp. I have it blown up, so it's a little bit fuzzy because it's bigger than it normally is. But we get a nice crisp, clear feed here that I can record from, which is super cool. And I can still also pass it through to a screen, so I can see whatever I'm playing there as well, if for whatever reason it's beneficial to look in a different direction, or if it's not fast enough to keep up with super real-time games. What's up, C. Grover? Or I should say, it's not that it's not fast enough to keep up, because it moves at the same speed, but it's got like a delay where you're behind by a half a second or so. It's rendering the same speed, but what you're seeing here is like half a second ago, which works fine for some games, including the game that we'll work on today. But for other games where it's like real time and you're trying to jump, like Nyan Cat, the Flappy Bird game I was working on last week, that one's a bit tough when you are behind time because you're trying to jump at the exact right second. It's a bit tough. What's up, C. Grover? Nice to see you this evening, my friend. So yes, today we are working on mice in CircuitPython land. Let me pull up the code that I have running here. And we will take a quick step through it, but there is not anything super duper crazy in here. I will point you towards, actually, if anyone wants to kind of play along at home, I know the Fruit Jam is not out yet, but you can effectively do this whole thing on the Metro RP2350. You would need the USB, what is it called, hub? CH33 or F something, I think. Yeah, this one. You would need this little doodad right here, but if you had this little doodad, you could do everything I'm doing today on the Metro RP2350 instead of the Fruit Jam. And then the one other thing I did want to pull up, and then we'll get right into it, is the mouse example. So what I am working with today is built on top of tests, CircuitPython manual, mouse, no, USB display IO mouse. So this is the base level. This one supports one mouse, and then the code that I'm actually working on. So if you want to grab it, it's in the core repo, test CircuitPython manual USB display mouse. And then this one that I'm working on here is very similar. So we'll step through it. We grab the default display, we get a group, we show our group, we create a bitmap for the mouse cursor. I'm actually using color converter, and I am using the tile palette mapper that we worked on last week. So this is kind of a cutting edge bit. If you're interested in the implementation of that, you could go watch last week's deep dive. But I am using that to change the color of each mouse. There are other ways to do it, but I felt like exercising that a bit since we were working on it last week. I have a list for labels. I have a list for mouse tile grids. I have a list for palette mappers. I have a color converter, and then I have a list for colors, and I have pink and green in my list of colors. Then we go loop 2 times. I'm creating that tile palette mapper for each one. On each one of them, I'm setting the third color, the color at index 2, to be from this list. So the first one is going to be pink. The second one is going to be green. We put that in our list. We create a tile grid using that mapper. We set its location. We add it to the list of tile grids. We add it to the main group. We create a label. The label has XY coordinates in it, and it also shares the same color as that index 2 that we put in the mapper there. Gets an anchor point, anchor position, so just one of them goes 13 pixels lower than the other one. We append that to the list. We append that to the main group. These are not actually used right now, but those are, I think, the VID PID of at least one of my mice. This we'll use to check when the buttons are pressed. This is one more list, which is going to hold the USB device objects, one for each of our mice. I found that I needed to put this sleep here. At some point, I'll raise an issue with this probably. I found without this sleep, though, I was getting past this loop and not finding all the mice the first time that the Fruit Jam boots up, and I added the sleep, and then I was able to, the first time it boots up, it finds both. So I think it's still, I don't know if it's like the CircuitPython trying to see if it's a keyboard maybe, and during that time we can't use it, or if there's just some need to wait for a second or whatever. I haven't tried lower times. I suspect probably a lower one will work, but I just stuck a second in there to start with. We loop over trying to find all the devices we can connected to USB. We print out VID PID for each one, as well as manufacturer product. Not all devices actually have these. Some of them just print blanks or whatever. Serial number is the same. Some of them print all zeros or 1, 2, 3, 4 or whatever. We append that device. So again, we're looping through that, everything that we found from USB host. We append that into mice. So we have our list. We're going to get our 2 mice objects. We're going to put them in that list. We are going to now go and loop over that list again. Realistically, this is kind of, we could have done this up here, but this code, I didn't take any time to really clean it up any. But it is doing this kernel deactivate. If I'm honest, I don't really know what this means, but I found it in the original keyboard example and kept it because it sounds important. I could put it up here. That's probably the right way to do it. Set configuration. This one I know for sure is important. If you leave this out, you get an error that says like no configuration set or something, basically. So we do that for both of the two mice. We detach it from the kernel if it's being used, and we set the configuration on it so that we can actually read data from it. We create a buffer so that we can store some data from the mouse. The basic mice only return 4 bytes. We should actually, let me print. I wonder if that is returning 4. That's it for setup. Then we get into our main loop. Inside the main loop, we loop over all of the mice that are in our list of mice objects. And then for each one of those, we are going to try to read. We'll wait for 10 milliseconds to see if any data is there. We'll try to read it. If it is there, it will get put into our buffer. I just, on the sneak, just added this little print here. So we're going to see if this actually maybe ends up returning more than 4, which could be problematic. If there is no data, then this timeout error will get raised and we just continue, which means basically we go on to the next mouse. Or if we were on the second mouse already, then we just go on to the next iteration of while true. If we did have data, though, then we will not get the timeout exception, which means we will come down here. What do we do in that case? We go and we grab our mouse tile grid, the one that is at the same index as the mouse object. We're going to update its X to a value. We're basically going to add the offset. However much the mouse moved, we're going to move the X of the tile grid by that same value. Same thing for the Y. However much the mouse moved in the Y direction, we are going to update the Y of that mouse tile grid. There is some bounds checking with max and min to make sure that it won't go outside the display. There is an out string which gets the coordinates. So the coordinates of the tile grid, and then it will also get from this list here, this is going to go and check if any of the buttons, like left, center, right buttons, are pressed on the mouse. If they are, it's going to add that to the out string, and then finally at the very end here, it's going to go and update the text on the label that is matching up with that particular mouse to the out string that we have compiled here with the coordinates and the buttons. And when we put everything together, we end up with our 2 mice here. We can move them both around independently. If I press buttons on them, then you see they will say whichever button has been pressed there. So that is our basic mouse. Let me check on the chats. What's up, Scott and Beata? Nice to see all of you. And Mark Gambler as well over on Discord. Could it be the device startup time? Maybe, or something, reading them happens in the background task that hasn't run. Sleep will trigger it. I do not know what it is or what it could be. I just noticed that it was happening. I noticed that I could like Control-C, Control-D in order to restart, and then it would work the second time. And then I had the idea to put the sleep in, and that made it work the first time as well. And I haven't really dug much farther. I was thinking time for allowing the device to complete polling, and one crowds out the signal from the other. Yeah, I think like something like that, I think, is a pretty good guess. Somehow the core is either trying to do something with the USB devices, or just trying to do something in general, and it's not ready for us to do that yet, is my best kind of guess. Nice, you can print the raw mouse as well. Yeah, we can print, you could print the data. I don't think we are currently printing the actual data. Like, we could print from buffer and get the actual just raw bytes that are coming in from the mouse. In my case, I'm converting those into kind of XY coordinates, and I've got the boundary checking on them. If you just print the raw bytes, then you'll be able to, like, it will keep going up as you keep moving right. It won't clamp at the edge, essentially. But you can use that data however you want inside your game. You don't have to necessarily clamp it at the edges. Enumeration is pretty slow. But it seems like it wants to wait before it starts, essentially. Okay. So we are going to try to turn this into a memory game, and I think the place where we start is we get a board of cards drawn, and we start trying to check if things are clicking on it. Our browser, that's right. Okay, so for anybody who doesn't know, memory, it's like a kid's card game. Cards, tiles, something like that. Memory? Okay, memory game, I guess. Yeah, it's this sort of thing. There's little flippable, like, cards or tiles. Like, in my childhood, these were, like, cardboard things. They're not quite a card exactly, but they're a little thick, like a cardboard. But I assume this is like, there's a million different variations. You lay them out in a grid. There are pairs of pictures or whatever, right? So this one is farm animals, it looks like, and there's, you know, 2 of each one. You flip them all upside down, you scramble them up, you lay them out in a grid, and then you take turns. When you play 2-player, you take turns flipping over 2 cards, and then your goal is to try to find the 2 that match. So if you flip over a sheep, then on your first flip, then you're trying to flip over the other sheep on your second flip. And you just keep going like that, and you kind of have to, like, you know, most likely you're going to flip over the sheep and then something else, right? You're most likely not going to get the one other sheep. You know, you're going to find a pig or a frog or whatever, and then it's your goal to kind of memorize where those ones that have been flipped over were, so that next time around on your turn, if you find one of the frogs, you can say, oh, I remember seeing the first frog, you know, in the top corner or whatever. So that is the game we are aiming for. And I have quickly thrown together these graphics for it, which I did not even export yet. So let's get these out of GIMP and onto the device. I'm going to just use indexed. And I'm going to put the pink at the beginning. Buddy, get down. Actually, let me put a copy here as well. And one on the drive. Okay, I think for laying out the board, I think I want to use grid layout from display layout, because that will give us the grid that I want and be able to put padding in between everything, margin, depending on how you think about it. Without having to do a bunch of the stuff that's required for a grid. I'm just going to do, I think, all of this setup right before main. We're going to make a grid layout. It is, we can, yeah, I guess that's fine for right now. Okay, so I'm going to be aiming for a size of 4x4 to start with. We have 320 by 240 total size, I think. I'm going to make this square. Yeah, let's start with that. This is adding a bunch of labels. Okay. So we're going to go for I in range 3, for X in range 3. Wait, do we want 4, don't we? We want 4. We can sprites. Just need the bitmap once, and then we'll make multiple tile grids. So I don't know that a list of them. I'll create a list of them. I don't know if we actually really need it. I'll delete it later. Okay, so we create each one of these. Bitmap will be the bitmap we created, sprites, and then see, are they in order? So the thing is, there is, yeah, they're not really in the most useful order. So let me actually hard front sprite indexes. I notice Pylint starts to complain now that these should be sets, I guess. We'll do that. So 0, 1, 1, 2, 3, 4, 5, 6, 7, skip 8 and 9. So 1 through 7. Oh, skip 8 and 9. So those are our card fronts. And yeah, so we'll say I equals I times 4 plus x. And then this will be, so default tile, actually, I'll make as 9, 10. I want to go with that one first. Default tile, I'll set to 10, and then, let's see, tile size is, these are 32 by 32 sprites, and then height and width, I think these will default to 1, but I'll put them to be specific. I think, oh, pixel shader is sprites. Pixel shader for now. It's a bit more manageable. Put that in the list, and then we'll also put it in the layout. I'm going to say this is the card grid. Grid dot add content, the thing we want to add, the grid position, the cell size. Add content. The thing we want to add is new TG. The grid position is XY. And cell size will be in group dot append out the card grid. I guess we want the mice on top of that though, so maybe we should move this. Before we really do stuff with the mouse. But arbitrarily right there. Okay, so we have no module named display IO layout. I'm just going to install that with Circup. In fact, we can just auto. That should get it. There we go. Now we have cards. And the mice are on top of the cards. The mice are having a problem where the entire rectangle is visible. Let me see if we can fix that. That should be easy, I think. We just need to do make transparent. I think I turned that off at some point. Oh, but we have the palette mapper, actually. Does that matter? Yeah, that totally matters. We might just undo this for now. Let me switch this back to just mouse bitmap. And then we have two mice, but they're uncolored. Let me put the color back because I actually thought the color was a nice touch. Oh wow, let me catch up again on the chat as well. Sorry. Memory had this version growing up. Saw the box art when you pulled up the image search, and the memories, no pun intended, came rushing back. Nice. Yeah. This is traditionally a turn game. Do you want to make it real time given Toon Mice? My intention is to make it a turn-based one, but I will say the thought of a real time one did cross my mind where you're also like racing against each other, you know, to go fast. There was a video on YouTube maybe a month or so ago, I feel like is when it got popular, that was about a real-time chessboard that was super interesting, which kind of triggered my thought of speed memory. So yeah, we're gonna go turn-based to start with. Maybe we'll experiment with real-time, maybe we add a mode for it or something, but yeah, turn-based to start. 95% sure that box is in my mom's house somewhere. I can't recall, was there a CircuitPython game library to handle some sort of plumbing like game engines do? There's not really, no. There are a couple of things that help, sort of. There is a library that I have created that's called Game Controls. It is in, I think, the community bundle. Did I put it? I think I put it in the community bundle. If not, then I'm definitely going to. This tries to abstract the controls. So like if you have a PyGamer or a PyBadge or a Pico system or a Pew Pew M4 or a couple of other devices, this will like make them all look the same for your game. You can just say, was the up button pressed? Was the B button pressed? So on. So that's like one thing that game frameworks tend to handle for you is input. This one does that for you. There is also older and less like used. There is tiled game experiments. This one isn't even a library, it's experiments. But inside of here is tiled game map, which is a CircuitPython file class that lets you use a map that you export from tiled, the map editor, the level editor, this thing. So that is another thing that game frameworks sometimes help you do. So, you know, there's two components that together are both things that some frameworks have, but there's not one overarching one. What's the name? Box2D. I would love one day for a Box2D implementation so we have physics and everything. But I have no idea how hard that is. Where were we here? So yeah, let's try to get the, I'm gonna go to, I'm gonna use a different way to make the color come back. I'm just gonna make 2 palettes. And we're just gonna say, works. I think I should be able to just use 0, 0 and the color I want. So let's say pink. Obvious ugliest list code ever, but that's fine. I'm gonna change that later. I think that will give us colors back. 6 out of range. 5. Oh, well, for one thing, this should be 0, 1, 2. And this. Oh, wait, no, it shouldn't. 1. Yeah, here's our problem. It should be 0, 0, but then it should be 0. Out of range. There we go. Oh, no, we're back to that. Okay, yeah, but that's fine. That we just need to go. Okay, there we go. Now we have color and transparency both working. Both nice. Okay. Just thinking of. Let's see. Let me catch up again on the chat. In player memory game using in input, but sure that can be a stretch. I don't know if we can go past 2. 2 is what we have on the hub on the board. Potentially, if you had a bigger hub or more hubs. Just thinking of the potential audience for the Fruit Jam and the inspiration being C64. And similar, one of the lessons that took me a while to learn is how to structure code to make a game. So a library, even as a teaching device or a template, just a random thought. Yeah, I will say it's in the works. Yeah, so the guides that come for some of these games are gonna try to approach a more general take on how to build a game, essentially. And there may be some kind of framework that gets born out of there. Spend some time thinking about the on first boot experience, a tutorial or an editor. That'd be pretty sweet. Okay, we got color back, we got the mice back, we have our cards. So let's start making something happen when we click. So now in our main loop, when we read data from the mice, we are in here. We know the mouse index. We're gonna be able to move the mice, and we're gonna be able to, in here, where we know if a button has been pressed. So what we're gonna do is say if button is, I'm gonna do, what is it, left is normal click. So we're gonna say if button is left, then we want to basically flip the card if a card was clicked. We're gonna worry about turns and everything in a minute, but I'm gonna start by just changing the sprite on the card. So let's say when we click a card, let's change the sprite to Blinka. So if left button was clicked, then what we're going to do is say if, what are we going to do? We're going to say if we need to go through our cards. So we're going to say for card in card TGs, good thing we got that. If the, let's see, card TGs, no, we can just do card. If card dot contains, this has contains, that is a tuple with x, y, and I think it actually wants a z as well. So I'm going to pass 3. So x and y are the values from this. Basically, we're going to say, is the top left corner of the mouse cursor inside the bounds of the current card? And then we're looping over all the cards, so we're going to find out if it's in the bounds of any card. And then if we find one where it is, what we're going to do is say card 0 equals whatever is Blinka. So 0, 1, 2, 3, 4, 5, 6. All right, let's see if that works. Nice. Okay. And this mouse too. Oh, I was outside. Oh, that one's not working. Oh, there we go. It did work. Okay. Is it skipping? Interesting. Doesn't always work. Not always work. It sometimes works. This one always work? No. See, it's going left up there. It's not actually working. Did I XYZ wrong? That should be... That's really weird. What was our thing printing, by the way? We are printing 4s. Okay, so we are reading 4 bytes. I wonder. Maybe it's say that it does though. Yeah. So I think that takes 3 because technically, oh, 126. The USB error. I think I've seen that just go. Oops, I just tried to Control C with that focus. Does that just work again if I reset? No, now we're just getting that. Okay, let me try reset this way. Weird. But this time I'm holding it down, moving a little bit. Okay, I think the I suspect that the grid layout is messing us up somehow. In fact, I think the problem is that I think the problem is likely that the grid layout is a group. Yeah, so grid layout is a group. Everything is appended to it. Well, not everything, but all the cards are. And we set its XY at 1010. I bet you that our XY values of the tile grid, they totally are not going to be taken into account that 1010. Hard reset, we leak some memory still. Gotcha. USB happens because we can't close the endpoints yet. Okay. So we can adjust for that by saying the tile grid of the mouse, I think we will have to go minus card grid dot x minus card grid dot y. Okay, yeah, totally. I think what was happening is basically we were shifted by 10 pixels. So part of the card back worked, but also part of the area outside the card worked. And then part of the area inside the card didn't because of the shift. But now it looks like we're good. Okay. Yeah, so that's because these are local coordinates of the tile grid, which is inside the group, and then because I moved the group, whenever we created it, right here, we put it at 1010. That means our local coordinates inside of it are actually not, They're offset from the screen, basically, and the mouse coordinates are not offset from the screen. They are exact on the screen. Okay, so that is one thing to keep in mind. Let's fix the pink. That should be easy, right? Pink, we should be able to just go transparent 0 on the pixel shader for the sprites. There we go. I don't know though. I think I do want some color, so I don't think transparent is what I'm gonna do ultimately. Maybe white? What does it look like if we do white? I don't want to spend too much time tinkering with the looks of it, but curious real quick if we just do one fast like this. Yeah, I think I like that better because I want to keep. It's supposed to look like a card, right? So transparent doesn't make sense. It should be on the rectangle still. Okay. Now let's work on what next? Let's work on turns next. I think turns is a nice, good, high-level thing to do. So I am going to say that we have a current turn index, which is going to start on 0. And what we're going to do is we are going to say when that click happens in here, if the button was clicked, and if we don't need that, and current turn index equals mouse index. So we only care about the click if the current turn index is on that mouse. So with the code like this, only one mouse is going to work, and I don't know which one it is, so we get to find out together. It's not the green one. It is the pink one. Okay, so pink mouse works right now. Now what we can do is when that happens, and we do actually do something, if they clicked on a card, we can change current turn index. I'm gonna make players 2. I guess maybe eventually you could share mice and have more than 2 players. But I'm gonna start with just 2. I'll make the variable though so that the code is hopefully easier to update later. Current turn index is gonna be equal to itself plus 1 mod of players, number of players. That's going to go to the next player. So we should be able to alternate between the 2 mice now, flipping cards. So green, I click and it doesn't work. Pink, I click, it does work. And then if I click again, it doesn't. But green now, if I click, it does. And then if I go again, it doesn't. Yeah, okay. So we are alternating. Now, of course, in memory, you don't just flip 1 card, you flip 2. So we'll need to worry about that at some point. Now seems like as good a time as any, I suppose. So, by the way, also, I should have mentioned when I started, it is really windy and stormy here. Well, it's like windy and off and on stormy. It's like sunny for a minute and then stormy for a minute and then sunny for a minute. Anyway, point being, my power is sometimes shaky, knock on wood. If I disappear, unfortunately, it's likely the power went out. So if I am abruptly gone, that is probably what happened. If it just blinked, I'll try to come back, but if it is gone, then it is gone, and that will be the end of the stream, unfortunately. Let me catch up on the chat here. Okay, hard reset. Green for the green mouse, pink for the pink mouse. If you mean, do you mean the text, or not sure what you mean? Yeah, I think they do match though. Yeah, pink text changes when the pink mouse moves, and green text changes when the green one moves. Has no one made software yet that can make simple games like import your own sprites and music and build it? It would be a multi-million-dollar idea. Software, import your friends, family, and make a quick game. I mean, definitely there are things like that that exist. Game Maker Studio is a big one, and there's like, I happen to have my Wii, or not my Wii, my Switch. I happen to have my Switch out today. Switch has Game Garage, maybe. Switch has a Game Maker thing though. There, you can make games on your Switch if you have that cartridge. Um, there's a lot of game frameworks out there. So like Phaser is a JavaScript game framework. Pygame is a Python framework for making games. It's not that these things aren't out there at all. It is something. I'm just watching my cat like look as if he is about to jump through the window at the leaves flying by. Oh, the color of the background. I see what you're saying. Yeah. I don't want to do pink and green because then the mice will get lost in it. Yeah, so there are game frameworks out there. There's just not an all-encompassing one for CircuitPython yet. But a framework is a tough thing on CircuitPython, right? Because a framework wants to like work for every kind of game. And CircuitPython is a constrained environment. We have limited flash and RAM. Now, the FruitJam has a lot of flash and a lot of RAM, as far as microcontrollers are concerned, but still limited, sort of. So a full framework that works for like every kind of game, platformers and top-down tiles and jumpers and shooters and first persons and, you know, all these different things is a bit much probably for one library in CircuitPython. But maybe broken up into different types of games. You could see there being helpers for each type of game, maybe each genre, so to speak. And then some more general ones like the tile map importer, right? The tile map importer, it doesn't, you know, there's different games you can make with a tile map. It could be a side scroller, or it could be a top-down tile thing, and both can be authored in the same tool. In the same loading code could work for both. How do we want to track the player's turns as far as like how many cards they have flipped over on their turn? Start with the easiest way first. Okay, so we'll say cards flipped this turn +1. Know where he's at. And then what we'll do is we'll say if cards flipped this turn equals 2, because you get to flip 2 cards, then we will change turn. So now each player should get to flip 2 cards before the turn changes. I thought you meant an outline to show which... Oh, that would be interesting. It had an outline so it would say, kind of like show you which player flipped it. Although it's going to get flipped back over too, right? So the way the game works is you flip 2 cards. If they match, then you kind of like get points, right? They get removed from the board and you get to keep them. You get points. If they don't match, then they flip back over. And so then you wouldn't see your pink and green anymore. I guess we could put the outline on the back of the card, though. Then you would see it. I think for now I'm going to keep it generic, though. I'm not going to worry about who flipped the cards just yet. Okay, so we flipped 2. So if I pink mouse, we should not be able to flip a third one. Oh, you know what we're going to need to do is update this back to 0. Otherwise, the next person's not going to be able to go. 1, flip 2. Try to flip 3, it shouldn't work. Okay. And then green, 1, 2, 3 shouldn't work. And then pink, we should be back to. Nice. Okay. All right. So now we can flip 2 cards and then the turn ends. Let's. How do we want to do some more of this? So let's work on randomizing the board. Right now, we're just always flipping to Blinka. Let's get the board randomized. And I think how I'm going to do that is... Can you turn a set into a list? Yes. And then can I just, like, make 2 of them, basically? Ooh. We probably just really wrecked that. Huh? No, okay, that's fine. Okay, so yeah, that's 2 copies of our list. They're in a strange order, but that doesn't matter. That's probably because sets are unordered. Yeah, so that's what we want. So now we have a list of 2 copies of each of those indexes. As we go through the XYs right here, what we're going to do is we are going to keep a card locations, which is I'm going to make it a I am going to make it a I'm going to make it a dictionary. And each time we go through this loop, I'm going to say xy equals... Is this going to turn it... I think it will turn it to a tuple by default, but I want to make sure that it definitely is a tuple. So then we want to choose one at random from the pool. So I will say random choice equals random dot rand change 0 length of -1. That is inclusive on both ends, I'm pretty sure. That's going to give us a random index out of this list. And then what we're going to do is chosen right. We probably don't need this variable, but I'm going to do it for now just to keep it straight in my head. Put this here. And really what we actually want to do is not do this, but instead like pop. That way it gets removed from the list, the pool. So we have a pool of all the sprites we want. We choose a random one out of it. We take it out of the pool. Next time through the list, we choose another one. We take it out. We choose another one. We take it out. Eventually, we've chosen all of them. They should get filled in randomly to these XY locations. And yeah, I think I can just put this. So let's do that. And then the last thing we need to actually see if this works is here when we flip a card, instead of doing 6, we are, yeah, let's see. We are gonna, okay, we're not gonna do XY. Instead, we are just gonna do I. Or, no. We're just gonna go back to a list. I think we're gonna go to a list. This is gonna be append. Append it to the list. Those are technically still kind of XY, but they're just flattened to a single int. And then the index within card TGs will match the index within card locations. So when we click a card, we can say card locations card TGs dot index of card. I think maybe that will work, maybe, possibly. Oh, not if we don't run it, though. Okay, no. Stop is not reachable from start. It's terrible. Okay. I assume that means the length of this is wrong, basically. So the question is, does that fail the first time or the last time? Fails the last time. I guess because at the end it says 0, 0? 0, 0 not valid? Yeah. Okay. Yeah. I'm going to put greater than 0. I know that I think the code will do the same thing, but it's more clear what it's meant for when it's this way to my brain. So if there are actually, but we need greater than 1 though. But yeah, we do need the code like this. So if there are greater than equals? No, greater than 1. Yeah, if there's greater than 1, we get a random one. If there's only 1, then its index must be 0, so we use 0. Here we go. Oh, pink is first. There we go. All right, 2 cards flipped, different characters. Let's just go and flip all the cards so we can see if we actually ended up with a board that has 2 of each. So there's our 2 rubies. There's our 2 Gus, the green one. I don't know the chip's name. 2 Blinkas we found. Betabots, 2 Ohms. 2 Minervas, and I already do 2 on green. Wait a minute. I think maybe double clicking breaks it. Anyway, we do have 2 of everybody, so that part worked. I think that clicking twice breaks it. We need to limit our clicks to only count if the card is face down. So if I click once, we get that, and if I click again, I think it would have just done the same thing again, and now I'm not allowed to take my second flip. Because I technically flipped the same card twice, essentially. Okay. So we need to say when you click a card, only do anything if it's face down. Oops. What was the index of this? 10, I think? 7, 8. Yeah. So if it is a flipped over card and it contains the thing, coordinates of. Oh, so we do reset. Could add that to the code eventually. I'm going to switch these mice around. So the one I grab first is actually first player. I'm going to click again, twice more, in fact, just for good measure. Okay, there we go. So now it does only count when you click on a face down card, basically. Okay, let's get it to flip the cards back over if they do not match, which also means we're going to start checking for matches. So Let's say that I think let's change this to a list, and that's going to contain the indexes of the cards. So this will say if the length of that list is equal to 2, then we reset it to an empty list and change the turn. And then here, instead of adding 1, we are going to append the index. The card. Okay. So now we will get indexes of each card that were flipped, which we can then look up in our list of tile grids, which we can then figure out which sprite is on them. So what we can do is when the length of this is 2, what we're going to do and go is say if cards flip this turn 0, so the first tile grid, if its sprite is equal to the second tile grid sprite. Not assignment though, equal. That mad. Class int does not define get item. Oh, right. Those are indexes. We need this. Our maybe we should just keep the tile grid in. If the sprites are equal, found match, else flip them back over. So in that case, that equals 10 because 10 is the flipped over one. So I'll make a variable out of that. Oops, we can't do this before though. It has to be after. Probably this should come after too. Okay. So if a match was found, what we really want to do is we actually need an empty tile, don't we? We need something to leave when there's no card. I don't know what the size of this thing is. Weirdly not pixels. All right, that is 1098. That is index 8. So if we found a match, what we're going to do is set both of those 8 instead of 10. And what we will also do is make a player scores as a list that starts with 0, 0. And we will say if they got it right, we will give them a point. I don't know what that's going to do, but back to the online suggestion, then leave behind the back to the outline suggestion, leave the outline color for the successful player. Maybe eventually. Not right now, but maybe eventually. And the reason I say not right now is because the colors are here. They're actually easy to change. Ultimately I want it to be where the players can set the colors. So like I'm using pink and green. If you want to use blue and red or blue and yellow or whatever, I want it to be super easy to just update this and get different colors if people want to use different colors, which then means we need a way to change the color of the sprites. We could use the mapper thing, but we use the mapper thing. Maybe the mapper thing would help. In any case, though, I'm not going to worry about the colors just yet, because I don't know the exact solution in my head, basically, of how do we make it to where it can also be dynamic, just like the colors of the mice. Because like it'd be super easy to make one tile with a green outline and one tile with a pink outline, right, in the sprite sheet, and then we have pink and green and we're good. But I do want to support being able to change the colors of the mice as well. All right, so we'll say player scores index of the player, which is the mouse index, plus equals, say. And it would probably be useful if we had these visible somewhere. So why don't we also do, when we output this, let's put the score here as well. Can we? Yeah, we can. Okay, let me move these down so we can see our two scores. Or actually, let me move the green score over instead of down. Eventually, we'll probably get rid of the X and Y as well. Leave these labels to be score labels. Output labels. So this will be, instead of this, let's say this. I don't know the width of that, though. I think... the width is going to change. Also another problem. Okay, how about we don't worry about the exact width and just choose something. Word? Okay, yeah. So we need, say, 100 times I. First one is at 0, the next one is... It's the wrong mouse. Okay, close. Let's do 120. 10. Good for now. Ink, let's see if the score works. Flip. Oh, okay, we need that to wait longer. We didn't get to see the one we flipped. Time.sleep. Us. Seconds probably will... 1 second might... Or the other thing we could do is... Okay, then the mouse doesn't move during sleep. I like the delay that way. I want to switch to polling monotonic or else. Um, yeah, I think so. So what we're gonna do is only maybe we should use ticks, right? Ticks is supposed to be the proper way to do this. I also don't know. Let's have mono. So we do this stuff only if now is greater than wait until, and we update wait until here to be 6 plus. So I think now the mice can keep moving, but it will basically ignore any more clicks. That didn't work. Right, we need to update that or this happens. Yeah. Um, Not the right code. I think. How do I want to structure this? I really don't want to use sleep, but I might just go back to sleep so that we don't spend too much time on it right now. Eventually, I will make a way, probably not blocking. So there's like these things. But this is also gonna. Um. Man, that's like breaking my brain. How do we wait without blocking? I know this is possible. I mean, this feels like such the wrong way to do it. Like this. But we also this or this. Okay, I can keep moving. Flips and then an index out of range. We need to turn that back to false because I think it did it a second time. There we go. Wait for the user to have a chance to see the second card before it flips back over. It was flipping the second card instantaneously. Flipping them. I guess we could wait for the next click to flip the other ones back over. I feel like that's kind of cheating in a way, though, right? Because then you don't have to remember the most recent two. You could just look at them. Yeah, so this is kind of what I want. You click two, and then you have a little delay. Like you have a second or two where you can look at the face-up cards, then the face-up cards go face down, and then it's the next player's turn. And you have to remember what was there rather than being able to see them. I mean, oh, it worked. I didn't. Did I change the code? You long enough? So weird. I swear it did. Oh, it doesn't go until the mouse moves. Because if there's no mouse data, we continue. This should be before. We don't need to do it. We need to do. Okay, that's why it seemed like it didn't work, because I didn't move any of the mice for too long. And it wasn't updating the screen until a mouse moved. Okay, so what I'm going to do is click 2 and then not move the mouse after. Click. We don't have now. We need to calculate now sooner. But okay, page up. Start a countdown from the second mouse click. I mean, that's essentially what we've done, right? Like when the second mouse click happens, we essentially are starting a countdown to 1500 milliseconds in the future. And then each time through our loop, we're checking, have those 1500 milliseconds elapsed yet? And do we actually need to do a reset? And then if both are true, we reset our flag there, we do our flips, we empty our list, and we change the player's turn to the next player. So we essentially are doing a countdown, but we're doing it based off of the time rather than just a straight number count or something, because I don't want it to block. Because while it was waiting with like time.sleep, or if we were to do like a while countdown or something, the mice won't update if the code is blocking. So this gives us a non-blocking wait, essentially, where like the mice can move, the game doesn't feel like it's frozen, but the players can't actually do anything. If they click during this window, nothing's actually going to happen. What we want. It's what I'm intending for right now, at least. Whether or not it's what we want might be a longer term discussion, but it is what I'm after at this moment. Control, what is that? -CDF? -CDF. I don't know what you mean there, Vince, over in YouTube. It's like DF? DF is a Linux command? Files or something? Did I run a command? It's earlier. I'm not actually sure when that got typed, sorry, by the way, as well. So it's possible that was from a while ago, and it was relevant to some command I ran at the time. Okay. Let's see if the score is working right, because I've been flipping cards. We have not actually we haven't found a match again yet. So let's try to, oh, that's somewhere, right? No, I don't even. Okay, blue in the top left corner, Adabot down there. I should have gone more. Oh, there's blue. Okay, so green can get blue and blue. Oh, this is going to be instantaneous. Is that okay? I guess I would really like a little bit of time there, truthfully. I mean, like, you know that you found a match because they disappear. But if I'm honest, I don't really dig. Oh, that also, the turns did not change. Oh, because now the turns changing happens up there. Okay, well, that's actually good. That's actually good. It's actually good. So what we're gonna do is, actually, what we're gonna do is we can just put this here. And then this whole thing moves up here. So that's two birds, one stone, actually. Because we were not properly changing turns when a match was found. We're still not. Fix that. Also, we're not emptying this. We should do that. Okay. There we go. So now we basically, once the second card is flipped over, we start that 1500 millisecond countdown waiting, and then we only determine the outcome at the end of that. There's two ohms, I think, right? Ohm and ohm. There we go. So we get to yeah, I like that way better than just disappearing instantly. Cuz like you got a match cuz they disappear, but like I think seeing them is really. That's true. Yeah. Good point. Let's do that. Uh let's do that. So only if they did not match. Yeah. We do still empty this though, because those two cards are gone now. Also, we will need I think we should say when a card gets clicked. Oh, we already have this actually. If it's flipped down, then we care about it. Otherwise we don't, which means if they click on an empty box, it will ignore it. Nice. That has got some emoji going in the chat there. Yes. That is awesome. Okay, so that should give us that behavior, I think. The go again if you get a match. So let's try to test that. Minerva and Ohm. Linka and Ohm. So then Ohm and Ohm. Oh, I didn't check if the score worked. Score work? Score didn't. Oh, score did not work. All right, well, let's check the play again though. It should still be pink now. Yeah. Okay, now pink is done. Already forgotten everything I've seen pretty much. Minerva is up there somewhere. You know, I'm pretty sure we've seen this one. I don't. That's fitting. The green got the green. Oh. Uh-oh. Did it count pink's score for green? Counted pink's score for green. Let's try to score again for pink. There's Minerva. That's up here. It didn't. Why did green get 2 though? Oh. Okay. Those don't update until you move the mouse. That's the same problem we had before. So those will update every frame, whether or not you move the mouse. Oh. Can't do that because now we're only updating it for one mouse. Okay. Go in there. And I guess what we will do is also do this here. It feels pretty wasteful to do it every frame, but I should have started in the Ohm. Okay, yeah, totally. Pink is counting for green, and green is also counting for green. Oh, also pink gets to go again though. Revenge. Yeah. Okay, green counts for green and pink counts for green. Why is that? Mouse index. Can't do that. Current player. Don't we have current player? Yeah, current turn. Just randomly click 2 again. I don't know why I'm not starting the corner. That was Ohm and Minerva. So we want pink to score. Chip and Ruby. And green. Gus? Bot and Ruby. Ruby before. Linka and Ruby said here? Nice. Okay, so pink scored for pink that time. That's good. Blue had oh again. Ohm? I've seen blue. Okay. Green is scoring for green, pink is scoring for pink. What should we do next? Heads green, yeah, heads green wins, tails pink loses. Yep. Let's play Circuit Python Memory. I'll play green. Yeah. It's like green and orange in the Stardew Valley in the wheel game. Um okay, what do we want to do next? We got about 15 minutes. I think the basics of the game going here. At some point we'll need game over. So like when the game ends, we could say who wins and we could like I have this little game over screen that I've been using for all of these games that shows the score. In this case we'll have both scores. And then it has like press P to play again, press Q to quit. We'll need buttons for that though. We can't use press P because there's no keyboard. This is the first one I've been doing that's a mouse. So we'll create visible buttons that say click here to play again, click here to quit. And I've been doing all of my games that way with a, you know, at the end, one action that plays again and one action that quits. And my vision for that is, which I think Scott talked about at one point, a launcher, right? Like a desktop or something where you could have a list of all the games that are on your device. You could choose the one you want to play. You play it, and then when you're done, you either play again, it goes back to the same game, or you quit, it goes back to the main menu for you to choose a new game. So I've been trying to keep that structure of all the games at the end. They let you play again, or they let you quit. Quit will go back to CodePy eventually, which I imagine being the launcher or the desktop. Although it could launch a different thing too if it's not in CodePy. But that's easy. I don't think we want to do that right now. What do we basically have a functional game. Is there anything we're missing for the actual like core functionality of the game right now? Minerva. Or Minerva this round. Chip we definitely have. Blue. 50-50, got it wrong. I think Adabot's this, right? Got it wrong again. Third time's the charm. Alright, so then this is where the game over would trigger. Like the consistency of the UX you've mapped out. Thank you. Alright, let's drop the XY stuff. We don't need that, really. Let's get rid of that. That's just left over from the mouse example. We can just have score. And then if we just have score, we can actually just update the label only when they score. Then we're not setting it every frame like this. Kind of waste. Oh. You need to update both scores, though. I'm going to make a function called update scores. I'm going to use underscore so this doesn't complain about reusing I. Oh. Oh, right. Outstring 78. Start those on empty. Randomly showing, or we could start them on score 0. It might be worth let me try this. The one thing I'm noticing is the mouse sensitivity feels fairly high. What's up, James Hill over on YouTube? Nice to see you this evening, my friend. Thanks for tuning in. I guess it's perfect now. One thing I want to at least experiment with is how slow does half mouse sensitivity feel? Will that be painfully slow? Maybe. I do think it's like ever so slightly easier to control. Of course, bear in mind I'm also like using a mouse way over here, which is not really, and then looking this way, but using a mouse over here, which is not really how my brain used to doing it. But this is making it easier to hit my zones, though. Are we stuck? Nobody's allowed to go? Okay. I'm pretty sure it happened. We must have seen some matches at this point, right? But I'm not. Memory is not. So he definitely saw Chip somewhere. Where? Ohm is here, I think. Well, the score didn't update. I never called the function. Created a function, we didn't call it. Set. Blinka and green. Blinka. Adabot. Adabot. That was fortuitous. Chip. Red. So we got green, chip, and red. Nerva. Blue. Nice. Red. Red? Red? Nerva. Nice. Chip. Chip. Green. So that was red, I think. Is up here? Uh-oh. Can't flip another card. I didn't change mice, did I? Nobody can flip a card. Hmm. So how do we get stuck without anyone being able to play? I flipped one card. So weird. Exactly how to get back to there. Huh, nice. Chip and blue. Adabot and red. Nerva and Adabot. Again. Put this. You could get rid of these prints too. That's an awful lot of spam. And what's red? We have red somewhere. Chip and red. We've seen Inca. Red. Okay, we're already, well no, now we're at 3, so this is where it happened. It didn't happen. Green wins because there's 2 cards. I don't know. Somehow there's a path. There must be a path in the logic where we ended up either on. Somehow we ended up on a turn that nobody's. But that should keep it to always being 0 or 1, which means there always should be one mouse that's able to go. I don't understand how we got into that. And it was after we flipped 1 with green, I think. Yeah. Time to grab some dinner. As always, thanks for the stream and education, Tim. Yeah, for sure. Thanks for hanging out, Yano. We'll see you around. Yeah, I'll be wrapping up here pretty quick as well. For anyone who's interested in this type of stuff, I will be back tomorrow morning at the usual time that I stream, which is over on my channel, 10 a.m. Central Time. And I drop links in the live broadcast chat, which is the chat on Discord that's right below me here, live broadcasts. I'll put links in there when I get started. 10 a.m. Central Time tomorrow, Central U.S. time. We had daylight savings also a few days ago, so yeah. Try to figure out based on where you're at if that affects. Like, it affected me, so see if it affects you where you're trying to watch me from. I don't know how it works everywhere exactly, because it's kind of a mess, but I'm really not seeing a path. At least in my head, I don't thinking of a path where we end up on nobody's turn, but somehow there must be still something. Must be something. We could, this doesn't need to do this. This doesn't need to do this. We could just check for the left button. We actually don't care about the right button or the middle button, and we are looping 3 times here. If we press the wrong mouse button, could we get it thrown off that way? Is that how we got? Let's take out this. So I'm gonna flip 1 and then I'm gonna like right click, middle click, try to click. Okay. Yeah, I don't know which path through the code led to that, but somehow we did end up in a spot where no one was allowed to play. So I'll need to figure that out at some point. But I think that is going to do it for the stream tonight. Like I said, I'll be back at 10 a.m. Central tomorrow. And I will, either me or Scott will be back at this time next week. So I tend to call it 4 p.m. Central because that's the time zone I'm in. 2 p.m. Pacific, 5 p.m. Eastern is what it's usually built in for Deep Dive. One of us will be around next week. I'll be back tomorrow. Yeah, I hope everyone has a good night. Thank you all for hanging out. Thanks for the folks in the chat. Yeah, see you all next time, and thanks for watching. All right, we have 2 OBSs now, so we need the other OBS.